Hey guys, it's Will, and I'm here with Technomancers. I'm one of the mentors for Technomancers, and I'm here with one of the students.
Hey, my name's Atosh. I'm one of his students in programming.
He still cracks me up with that. Anyways, he is one of our lead programmers, actually. He did most of the code that's written for our code this year, 2017. And he did an amazing job with it. We got autonomous working towards the end. Hopefully we learned a lot and we can push towards and teach everyone else what he has learned. And before I forget, because I did a whole video on this without sharing my screen, there it is. Anyways. So, what we're covering right now is object-oriented programming, or languages. Specifically, we're going to be talking about Java, but today I'm just going to try to go over the basics and the ideas of everything. Java is not the only object-oriented program. We have C#, C++, Python, Ruby, Perl, Scala, all this and that according to Wikipedia right here. According to Wikipedia, object-oriented programming is a programming paradigm based on the concepts of objects, which may contain data in the form of fields, other known attributes, and code in the form of procedures, other known as methods. A lot of words put into one sentence to try to get that description across. Let's break it down. Objects, attributes, which I call properties, and methods. So let's go over and let's start talking about it. As for object-oriented programming, there's objects. Objects you can think of as physical objects. They don't have to be physical, they can be ideal objects, but it makes a lot more sense when you're talking to somebody and trying to teach it to talk about physical objects. So today, objects we're going to talk about, let's call vehicles. Vehicles is very broad, and it covers a wide range of things, but you'll see why we do that, because then I want to cover inheritance as well. With vehicles, we have cars, so I'm going to put that down here. So we have cars, trucks, SUVs.
Normally with inheritance or objects like that, if you can say like a car is a vehicle or a truck is a vehicle, normally then you can say that it's an object of vehicle, and that's or you can say it inherits a vehicle, and you can use that to connect it. The is a test.
Yeah, definitely, and that's what we're trying to head with. So we have cars, trucks, SUVs, and let's go motorcycles as well. Right? And as Atosh was mentioning, as with inheritance, I could say a car inherits from vehicle. A truck inherits from vehicle, SUVs, and motorcycles. So they all inherit that single property of vehicles. So an idea of a vehicle. What does vehicle cover? Atosh, what are some properties of a vehicle? Not cars, but vehicles in general. Properties, not methods.
They have wheels.
So maybe number of wheels, right?
They have motors.
Motor type. Let's say doors. Even though motorcycles don't have doors, we can say that a motorcycle has 0 doors, right? So we'll just do number of doors. Is there anything else?
Right.
Alright. Let's just stick with that. We just need a few properties. We don't need that many, just to get the point across, right? So these are properties. Let's also go over methods. Some of the methods that can be involved. So what are some methods you could think of as verbs? So what does a vehicle do? You said drive? Brake? Is there another one that you could think of?
Yeah.
And turn. There we are. So that's in general what a vehicle covers, right?
Yeah.
So then let's see. Now we want to create a car, right? Well, a car inherits. I'm going to use 2 dots to say inheritance. In other languages, you do inheritance different ways. This is just a general, so just know that the colon means inheritance. So a car is a vehicle, or of type vehicle. Now whenever we create a car, we say number of wheels. How many wheels does a car usually have? It's 4. Motor type, for this car, or for general cars nowadays, we'll just say, I'll say V4. Just for now. I know there's a lot of differences there, and cars just a very, it could be another, part of the inheritance tree, right? You can have sports cars or something like that, but I'm just covering very general basics right now. And then number of doors, if we go with the sedan, we'll say 4 as well. Very simplistic. But then a motorcycle would still inherit from vehicles, right? But number of wheels would still equal... You only have 2 wheels this time. Motor type... it'll probably be a V4 still. Just a smaller volume. Number of doors. Also, I'm a programmer, not a car person, so don't quote me on a lot of these things. And 0. But now what's nice, when we inherit from these vehicles, I can say car, let's just say car.drive, and the car will drive. Now, nowhere in here did I specify car, or drive, right? I just specified motor type, number of doors, and number of wheels, and then I told it to drive. Well, how can I do that? Well, I could do that because it inherits from vehicle, right? And since it inherits from vehicle, it inherits all of these properties and methods on them.
Right, and you can say that because vehicles is the superclass of the motorcycle subclass.
Yeah, I didn't know that was the name of it, but yeah, superclass. So.
That's why you say super in a constructor, like super open parentheses.
Some languages use super, so that's a good point. You could use super, and then what, dot property name or something?
Yeah, you have like a constructor for vehicles. You have a constructor with wheels, types, and door. Super, if you just type super with wheels, type, and doors in the car subclass, you automatically inherit all those methods and the vehicle. And so it just matches all of those, so it matches them all to the constructor of the superclass. So you have all of those methods, which is really neat, and it saves a lot of time and space. And
it keeps you from copying code, right? But let's not get confused. Super is one of the words, but you can also have base. I think C sharp. I think C sharp uses that one.
Java uses super, and I think C++ uses base.
Yeah. I think most C languages, so I'll just do CL for C languages. So C sharp, C++, C, I think use base. Alright, so that's enough with just objects in general. We went over properties and methods. Something else we wanted to cover, kind of lost my train of thought. What else did I want to cover?
You wanted to cover
constructor methods and interfaces. So Atosh kind of hinted on this, constructor methods. Well, constructor method, so let's go back to cars, right? Well, how do I create a new instance of a car? You would say new car, and then you would put in parentheses usually some values.
Hey, we can't see the new.
Oh, thank you.
Code.
I forgot my my camera. You know what? I'll just scroll later. Alright. This is why I stay on this view. Alright. There we go. Sorry about that.
You're creating an instance of the car subclass.
Correct. Yep, so we're creating cars with values. So something of value might be, let me actually get rid of this real quick. Something values would be number of wheels. So we'll pass in the number of wheels. We'll also pass in the number of doors. And the number of, not number, the engine type, right? Motor type, right? So that's what we're going to pass in. And that creates a new instance of car. But this car would be a Jeep, right? So we'll say Jeep equals new car, and number of wheels would be 4, number of doors probably 2, and motor type is probably going to be a V6, right? And then if we want a sports car, so we're just going to call it sports, equals a new car, which equals, since we're still using number of wheels, sports car has 4, Number of doors, we have, let's say a sports car only has 2 doors, and a motor type, probably a V8, because it's a sporty car, then a sedan. I think we kind of get the idea with this. But you could see how you could pass in different values. So a sports car would have 4 wheels, still 4 doors, and probably only a V6 engine. Right?
Can you define the type of these like things like Jeep, Sport, Sedan? What's a cool thing, even though there might be like a car or a motorcycle, whatever, before you give the name, when you actually initialize it, you can use vehicle for all of that, and allows you to do something cool called polymorphism. That's a part of inheritance. And so I can say vehicle Jeep equals new car, vehicle sports equals new motorcycle, whatever. That's really cool for just doing cool stuff with objects.
Yeah, that covers a little bit more of the advanced stuff, which object-oriented goes into way deep stuff, and I think some languages cover more, and some languages don't cover as many.
It's huge in Java.
Java is a big object-oriented language, though. So, anyways, that covers all cars. So now we have a car object that we can create different instances of. So now if I say sedan.drive, right, this does not drive all cars. This just drives the sedan object, right? This doesn't drive these. These two are still stopped. I could tell Jeep.turn, and Jeep would finally turn. But it won't move because I didn't tell it to drive. So they're all different objects, even though I created a new instance of them. You gotta think of them as separate entities. So yeah, that kind of covers the constructor. A constructor. That's how you construct an object or instantiate. An actual constructor would look something like this, though. You'd have a class car. And then you probably have your curly braces, you'd in curly braces, and then you would have a public void, because a constructor doesn't return anything. And I'll come back to what these two mean anyway. So public void car. And this is where you could say, hey, I want no arguments passed in. And this is where you could call, hey, I want super dot something equals something else, right? So this is where you're actually creating your object and what variables you want to set everywhere. This public means, hey, I need this to be facing outside of this object. I need other objects to be able to see this. Void means this is your return type. Since we're not returning anything, you have to be void because you're not expecting to return anything. But you can have something called an overloaded method, right? An overloaded method would allow me to create 2 constructors for this object. So I can create another object called public void car wheels, right? Number of wheels. And then we'll say super dot num wheels equals wheels, right? And that would be it. Now, the language itself is smart enough to know which one you want to call. If I call a new car with no parameters, it's going to call this one. But if I call a new car with a 4, right, then it knows to call this one. And because let's say the number of wheels is an int type. What you need to be careful with, though, is you can't have an overloaded method with the same parameter type. Or method identity, I guess is probably the more proper term for that. And what I mean by that is I can't just say public void car doors, right? Because doors is also of type int, right? And I want to call super whatever. I'm just gonna. It's the same thing as above, but you can't do this because then if I call a new car, the language doesn't know which one to choose. It doesn't know to choose this top one or the bottom one. So it does. It's ambiguous case is what most languages call it. There's an ambiguous case. I don't know which one to call. I'm gonna throw an error instead because I don't want to call it the wrong thing. So it's gonna be an ambiguous case. But what you can do is you can create a third one with int wheels, int doors, and you have to require them to have both. And it works because then it's like if I have one integer, call this method. If I have 2 integers, call this one. And that kind of covers the basics of constructors. So we also went over properties. Properties on, yeah, so, anyways, so a property may be a simple, we already covered the little bit of properties, but to go back to it, so we have a public class, well, I can't even spell, public class, car, right? Now, a car would also inherit from, so let's just go into a little bit more details here. I don't think Atosh minds with me going into detail.
No.
So I'm just gonna, for simplicity's sake, use a colon for inheritance. Some languages actually say inherit. Some of them use colons. Some of them use different words depending on your language. But public class car, and then we're gonna, or extend. I think extend's another one. So then we're gonna extend from vehicle, right? Now remember, vehicle has like number of doors, number of wheels, and motor type. Well, a car, what's different from a car than a vehicle, Atosh? Just to get a little bit more specific, what does a car have that a vehicle, not all vehicles have?
A car has a steering wheel.
Okay. So we automatically know that there's a property called a steering wheel. Probably it's going to be a boolean, so we'll just name it true. This will probably be a public constant, because that won't change. It always has it. So a public meaning, hey, anything that inherits from car knows that car has a steering wheel, or that is true. And sorry about that, I didn't mean to mess up with people's ears. Alright, so another thing, a gas pedal, right? It has a gas pedal. Wow, that was sluggish. I will just say that equals true, and I'll just it's still a public constant. Stuff that might be private to a car that other things don't need to know about, that's a little bit more complex, so let's not get into that. Let's just stick with this public stuff. I mean, I could talk days about object-oriented, but for basics, this is what properties are. So it still has number of wheels, number of wheels, number of doors, motor type, but specific to a car, it adds steering wheel and gas pedal, right? So now car has 6 properties on top of it. And since we already know it drives and it turns, and it also has, and it can also stop, it can brake. Well, something else it can do is, let's say, turn on brake lights. Turn on brake lights. And yes, we're repeating stuff that can be put into other things as well. This is just to prove a point, right? So this would be public void, because this doesn't need to return anything. This just needs to return, hey, well, I just want to turn the lights of the car, right? And this is a method. This method would get called whenever I want to turn on the brake lights of a car. Now, a vehicle doesn't have turn on brake lights, only the car. So this now has 4 methods to it. It has drive, turn, and brake, but it now has turn on brake lights. Something that might return something, just as a little teaser, public, let's call it a float, or a double, or whatever language you're using uses different things. We want to, let's see, get gas mileage, right? Get gas mileage, and that would return a float, or how much gas mileage this car has. Because maybe that changes. That's not something that's constant, or it's a variable, but this variable might be a private gas mileage that not everything sees and has to go through this method. Or maybe you need to calculate what gas mileage is. So you would go through this method to calculate it and return that value, instead of having to put it into a variable every time whenever you need it, because it's a calculated value. So steering wheel, you don't need to calculate. Gas pedal, you don't need to calculate. How many wheels, you don't need to calculate. But you do need to calculate that gas mileage, therefore it's not a constant value. So you really can't put it in a property, so you need a method for it, and that would be a getter method. If you go into other languages, you can still create a property, but it would have getters and setters, and one of the getters would be a function that would return gas mileage, and it gets very more complex, but this kind of covers the basics of object-oriented languages. I can't really think of anything else to cover. Atosh, do you have anything else?
Nope.
Nope. Alright. Well, thank you guys for watching. If you like this video, please like down below. Subscribe to our videos so you know when we are live next. That way you can stream to us live, talk to us live. Thank you guys for watching.